In this chapter, you will learn what natural gas compression is, why and where it's being used, who's using it, and how the process works. We will also cover the main types of compressors that are used in our industry and look at some of the differences between high and low pressure compressors. Natural gas compression is the process of squeezing gas molecules in order to increase gas pressure. Natural gas is compressed to enable it to be moved from one place to another. This may need to be done for a variety of reasons, such as to help lift resources to the surface, to create a pressure drop to condense and remove liquids from the gas, or to help achieve gas processing requirements. Compression is used in every sector of the industry whenever conditions do not normally exist for various processes to take place. Upstream producers use compression to inject gas back into a well to aid in lifting liquids to the surface. They also use it to compress low-pressure gas from tanks, control devices, and other equipment to help dispose of fugitive gas emissions. In the midstream, compression is used to move gas from one location to the next through miles of pipeline. In the downstream sector, it aids in the removal of liquids to meet consumer and safety requirements. Gas is compressed from 0 to 2,000 psi in the upstream sector. Midstream and downstream can compress in excess of 2,000 psi. Compression is done by increasing gas pressure in stages until reaching the desired delivery point. The starting pressure, desired ending pressure, and the volume will help determine how many stages a compressor will have. A compressor may be as small as this one shown here. This single-stage model is used to gather fugitive gas and send it to the combustor or flare. It is known as a vapor recovery unit or VRU. Compressors aren't only for natural gas. Here is a small air compressor housed inside a shed at a tank battery. Many producers are compressing air to be used for instrument supply. They do this to cut emissions and lower their environmental impact. This medium-sized compressor can handle larger volumes and higher pressures. This may be found at the wellhead for gas injection or in a small gathering system. The largest compressors are found at compressor stations. These are the engines that power a pipeline. The size and number of compressors vary based on the pressures and volumes of gas to be moved. There are two main types of compressors used in our industry: reciprocating and screw. Reciprocating uses pistons and positive displacement to compress the gas. Gas enters the manifold, flows into the compression cylinder, and then is discharged at a higher pressure. Screw compressors use two meshing helical screws or rotors to compress the gas. Gas enters the suction side and moves into the threads of the screws. As it does this, it is compressed and then exits the discharge at a higher pressure. This video shows the inner workings and the flow path of a three-stage reciprocating compressor. The inlet flow or suction side of the compressor starts at 30 psi and 80 degrees. It enters the inlet scrubber and any free liquids fall out. At the first stage of compression, the pistons will compress the gas to 155 psi and the temperature will increase to 260 degrees. As it exits the first stage, it goes into the intercooler. This cools the gas down to 120 degrees. The heating and cooling of gas along with the compression makes more liquids fall out of the gas. From here it enters into another scrubber so that the liquids can fall out. The second stage of compression increases the pressure to 490 psi and the temperature also heats up to 270 degrees. From there, it's back through the cooler to get the temperature back down to 120 degrees. With more pressure and cooling, there's more liquids that will fall out in the last scrubber. The third stage of compression gets the pressure up to 1200 psi and 240 degrees. Once again, the hot gas will go through the cooler and exit at the discharge at 120 degrees. Some producers will run the gas through one last scrubber to give any remaining liquids a place to drop out. This is a simplified rendering of a low-pressure single-stage compressor. The red components are Chemray products that are used on a system operating less than 300 psi. This is a similar rendering, but of a high-pressure single-stage compressor. The products all have the same function, but all of them have a higher working pressure of above 300 psi. You will need to know the basic flow and connections of a compressor when talking with a customer. Gas flow comes in through the suction control valve and into the scrubber. From the scrubber, it goes to the compressor, then through the cooling fan and out the discharge. If the suction pressure drops below set point, the low suction recycle valve will open and pressure will go to the scrubber. If the discharge pressure goes above set point, the high discharge recirculating valve will open and send pressure to the upstream of the suction control valve.